There are a lot of ways to program in C#.net or ASP.net to create web applications. Typical ways are using React or Angular as the front end with a web API backend. But a more simpler and perhaps traditional method is using Razor pages to create your front end in conjunction with your web service calls as well, without using an actual REST API. So I wanted to walk through a little bit of advanced object-oriented design or perhaps basic object-oriented design to create a table of employees that will display, and we'll render we'll create a base class and two concrete classes that inherit from that base class, along with some overriding methods as well. We'll use an abstract base class and we'll do two sealed classes, which cannot be inherited from. And we'll use a table that will render in a Razor page to display the list of users and let you edit them on the page. So to give you an idea of what we're creating first, if you take a look at this application here, you can see how we have the list of users are displayed here, and you can actually edit their names if you wanted to. You know, you can add different names here and perhaps edit some of the text. This is just using the content editable field in HTML, so nothing too fancy there. And then you would hit the save button and or the delete button. You can also add a random employee, and I'll show you how all of that works in just a moment. But first, let's take a look at what these employees look like. So I've organized my project, you can see here. I have the main ASP.NET Razor pages. The pages are hosted inside here. We'll get to that in just a moment. And along with that, I have a types class library. This is a DLL. It has the abstract base class for the employee type and the two concrete types for two types of employees, salaried and hourly. And we're going to add a new one into this. I'll show you how that works. And we also have a manager class, which is sort of like a helper utility class for retrieving employees. So if we take a look first at the types, here's our base class for an employee. So you can see here how the employee class is defined as abstract. An abstract class cannot be instantiated on its own. You have to inherit from it to create a concrete class that will then utilize this as its base. Within this common base class, we've defined an ID, a name, a department, and a method that the concrete classes will have to implement called adjust salary and get rate. And as well, we're overriding the toString method just to output the ID, name, and department. And notice that we're using the new format for including variables in strings that you can see right here. This is similar to JavaScript with the backtick. It makes it a little bit easier to display variables. So one important aspect is that the ID parameter is read-only. It only has a get property, whereas the others have get set. So get set, these property initializers mean that you can read and write to the field. Now, the ID, we don't want anyone to be able to change that, so it's read-only. In addition, we're initializing it to an ID of our choice from a generator. If you're curious how that generator works, you can just look. It's just a static class. A static class cannot be instantiated. You simply reference it directly. You would just type ID generator. Well, you could see it right here. ID generator dot whatever static method that you want to execute. All this does is it just maintains a variable, a static variable that starts at 1,000 and just increments it every time we generate an ID. Now, is this distributed? No. So would you use this in a web application? Well, you could use it on a single hosted web application, but if you're doing a distributed hosting environment, such as in Azure, where you might have the application hosted on multiple VMs or multiple instances or regions, then you're going to want to use something like a database, preferably with an auto-incrementing ID or Redis or something like that. But for the sake of our application here, this will suffice. So name and department are required. That means that they have to be provided with a value before exiting their constructor or in the property initializers. Um, this makes sure that a name and department will always be populated. Adjust salary and get rate are both declared as abstract. Just like the class, this means that they must be implemented by any class that inherits from this. So let's take a look at the concrete classes now. You can see here in concrete we have hourly and salary. They are both defined as sealed. Here's salary, also defined as sealed. That means that no other class can inherit this class. This is the final class. No one can change it. We inherit from employee, and you can see we are overriding adjust salary and overriding get rate. Those were the two abstract methods that are required to be implemented by the child class. And that's exactly what we're doing. And we're just providing a definition right here that you can see. We're just increasing the hourly rate based upon a percentage and returning it. And all we're doing in get rate is we're just returning hourly rate. Now we're doing this because our hourly employee has a member defined, a new member defined property called hourly rate. And our salary employee has a property defined called salary. Those don't exist in the base class, right? Those don't exist in the base class. So they are unique to these two concrete classes. However, the base class will still need to be able to call get rate. So this is the secret behind polymorphism. So we can refer to those two concrete classes by using the base class employee. And then if we want to call the common method to get the rate, their salary or their hourly rate, we can just call get rate. And that will execute the hourly employee's get rate, which will return the hourly rate property, or it'll execute the salary employee's get rate, which will return the salary property. So that's pretty cool. Of course, we are also overriding toString, and all we're doing here is we're just taking what the base class gives us, right? What does the base class give us? It's right here. ID name department, that's common. And we're just appending onto that the hourly rate. And for salary, we're appending onto that the salary. So that's pretty cool. So what if we wanted to create another type of employee? So we can do that by doing new C# class. Let's call it contractor. Okay, and we will inherit from the base class employee. And we can actually use IntelliSense to implement it for us. Adjust salary. Let's what should we do for salary? Can you adjust this, a contractor's salary? I suppose you could, but they're usually hired for a specific period of time. So in fact, let's define that first. Let's say public int, should we do weeks? Let's do public int weeks. Actually, let's do this. Let's call it contract length. Contract length. And it will be a get set, which will specify how many weeks the contractor their term is for. Adjust salary will not exist because you cannot change the length of this. So we will just define a message here and say unable to change a contract's payment terms. Okay, that way, so you can't actually adjust the salary. We'll just throw an exception there. For get rate, we do want to set what they have. So what we'll do here is we'll have a contract length, and we will have a public double. Let me see, what do we define the others as? Yeah, doubles. We'll do double. Public double contract. Actually, let's just call it rate. We'll just call it rate. which will be the entire contract's amount that the person will be paid. We'll give it get sets. And okay, very good. There's our rate. So now for get rate, we can return our rate. And likewise, we're going to want to include a toString method, just like the others have, because we're going to want to output our specific rate. So we'll say it's not an hourly rate, it's a contract rate. So we'll say per. Now, what we can do here is we can actually output, let's put the contract length, right? Rate out of contract length weeks, just like we have per hour. Actually, I guess we should do rate per however many weeks. Okay, that looks pretty good. I think that looks pretty good. So now we've defined our new type. If we take a look at the manager class, you can see here how we have a couple of utility methods for generating a random name. This just selects a random first name and a random last name and just returns that string. We have it generate a random department as well. And we also have, here's our generate method. This is almost like a factory method for generating an employee type. This is polymorphism. So again, we're returning an employee base class, which will be instantiated from either a salary employee or an hourly employee. And now we can even add a contract employee. We'll do that separate from this. So we won't do that yet. And this is just to add multiple employees. We're just returning an IEnumerable, which is like a list of employee. So, okay. So that's the manager class. This is the contractor class. Let's put it to use. So if we head into the Razor ASP.NET application, you can see here how we have our, we don't have controllers because we're actually not using this. In fact, we can delete that. We're using pages. So you can see here is our home page, okay? So this just renders a partial view for the employee table, and I'll show you that in just a second. And we have a form with an add button. And we have, here's the partial view, it's under shared. Here's the table. So you can see this is just a standard HTML table. We're referencing the model in index model.employees, which is a static variable. And all we're doing is we're just pulling each employee, which is the base class, and we're rendering the name and department and get rate. Remember, those come from the base class, from employee. And then we are also including fields to update, which will save back onto the employee record by doing a post to the save method. The same thing with delete. We can post to the delete method, and all we need to send is the ID. So if we take a look at how that works back in the index.cshtml.cs file, you can see here how we're actually not even using logger, but we've defined a static list of employees that are being generated randomly. Okay. Get will return the home page where we can then reference this model for employees. When we add a new employee, you can see that we're doing it right here. We're just adding it to the static list by generating a random one. And we have a couple, and when you delete, actually, hold on one second. When we delete, you can see what we're doing is we're filtering out that ID. We're selecting all of the employees except where the employee, we're selecting all the employees where they're not equal to that ID that's being passed in for the delete method. And then we return the partial view for the table. That way we can render it using Ajax. That's a little bit fancier. Don't worry so much about that just yet. More so about the onPost method. Save is similar. We pass in the ID, name, and department. Again, those come from the hidden input fields that you can see in the table, which was in the shared right here. these three hidden input elements get populated when you click the Save button. And they are, and then they are updated. Here we update the name and the department, and we select based on ID. We find that employee by ID, and that's how we can update a record. So let's suppose that we want to add a contractor type. So what we can do is, so we can actually add onto our employees array by adding a new contractor, new contractor, and we'll just initialize the properties right here by saying name equals Sarah Diamond, department equals, oh, let's just say software development. This is a contractor, so contract length will be, let's say, oh, I don't know, maybe 24 weeks. And rate will be, oh, let's say 75,000. Not a bad amount for a contract rate for about 6 months or so. Okay, so if we run this, we should expect to see a new user show up. So let's take a look here. Sure enough, here's our list of users. And we can see here, there's Sarah Diamond, software development, 75,000. And if you hover and we see the tooltip, you can see it indeed says 75,000 per 24 weeks. That is a contractor being rendered as an employee. Now, again, remember that we can actually edit. So we could do like, say the third, hit save, and notice that the page doesn't even refresh because it's doing an AJAX request behind the scene. So even though this isn't a single page app because it's just Razor pages, but the data is being persisted, which is pretty cool. So we can also delete entries, see, and it updates the HTML accordingly. And again, we can even add random items. This is just using the generator method. Again, if you refresh, everything's maintained because these are static variables. So that's all pretty good. Okay. So what if we want to add an alert or a confirmation before we delete someone? Currently, you just delete and it just erases them. Let's see how we can just add a quick little confirmation. So the way that we can do that is we can go into the Razor page right here. And actually, we will go into the shared table view and we can add a confirm on the delete button. So we can see here how we have class equals Ajax form. Where's that delete button? Here's the delete button. Class equals delete. We can say on click equals on delete. So we can define an on-click method with return on delete, and we'll just pass in the event. So back in our JavaScript, we can define a new method called onDelete, where we're just going to access the target from that form event, and then we can pass in the name from accessing the closest TR. If we take a look at that table again, you can see here how here's the delete button. So we're looking to jump up to the table. There's the table, the closest TR, and the first TD, which has the employee's name. So once we have that, we can access the inner text, grab the name, and include the name in the confirmation dialog. And then we can just say if not confirmed, we'll cancel the event and it'll return false. Otherwise, it'll return true. So if we save this and we take a look back at the page here, let's just refresh the app. And hopefully this works. So if we take a look at the delete, yeah, sure enough, you can see we're getting a confirmation dialog now. We can go ahead and delete them if we want to, or we can cancel out if we want to. There's the contractor that we added. Maybe delete them, maybe add a couple of new people, delete some more. Okay, so we've successfully added a delete confirmation. And just to go back over our code for a bit, so that is the JavaScript reference. You can see here how we have a partial view for the employee table. And we render the partial view in the main page along with the add button. And all of this comes from our Razor page that you can see right here, where we are instantiating a list of base class employees generated randomly that consist of 3 different concrete classes. Those concrete classes come from our types, where we have a base employee class and 3 concrete classes defined here. And by the way, if we did try to call adjust salary on the contractor, let me just show you what that would look like in just a second. Suppose that we went into our pages and perhaps in get we were to call employees dot last. We'll send it to the contractor, and then let's say that we want to call adjust salary and pass it in 1, 2, 3. I should say 10%. We should get an error if we try to run this because that method is not implemented. Yeah. So sure enough, you can see here, not implemented exception. Why? Unable to change a contract's payment terms, which is exactly the error that we put in. So if we stop this, you can see here, it triggered that. So I think that's pretty cool. We've done a lot here in putting together this application. And you can see that creating a page in Razor pages in .NET Core is not that difficult to do, and it's very similar to an Angular or React app, except that we're hosting all of the client rendering code. The page behind code, along with the access methods, are all directly in .NET, and we're not using a front-end library like React or Angular for this. Now, I wouldn't necessarily say do not use React or Angular. I think that is the right way to do it, to manipulate the objects in the client. But if you want something simple without adding additional frameworks for a very small project, perhaps Razor Pages will get the job done for you. And with that, I hope that you found this interesting and enjoy programming in .NET.